Good evening, friends. Today we continue our journey in the chapter electricity and we study Ohm's law. Now, Ohm was a scientist and he gave a law related to electricity, and this is a very important law. 100% it will be asked in exam. How is it asked in exam? They ask define Ohm's law. What law did Ohm give? What is the relation between potential difference? What is the relationship between potential difference and current? So all these questions are asked regarding Ohm's law. Okay. So what experiment did Ohm do? Ohm set up an electric circuit in which there was a nichrome wire of 0.5 length, an ammeter, a voltmeter, and 4 cells of 1.5 voltage each. Nichrome is an alloy of nickel, chromium, manganese, and iron. Using one cell, note the ammeter reading. Ammeter will give the current reading for I for the current and voltmeter reading for V for potential difference across the nichrome wire. Repeat this using 2, 3 and 4 cells. Basically what he has done is, when he has used one cell, the current reading came 0.5 ampere and the potential difference was 1.5 volt. So when we divide V by I, we get 3. When he has used two cells, he has got 1 ampere current and 3 volt voltage. When you divide V by I, you get 3 ampere. Okay. Then again what he has done is current 1.5 ampere and voltage 4.5 volt, so he has got the reading as 3 ampere. Okay. Fourth time when he used 4 cell, current came 2 ampere, potential difference was 6, and the V by I ratio remained constant at 3. Okay. So what was his law? He stated a law and he said that in any electrical circuit, the potential difference and current both are directly proportional, and to remove the proportionality symbol, a constant is defined such as the resistance. The constant is resistance R. So the resistance formula ultimately becomes resistance R is equal to V by I, voltage by current. Okay. So in this case, V by I value is approximately the same. V by I graph is a straight line. Thus V by I is a constant ratio. So number of cells used kept increasing. Current through the nichrome wire kept increasing. Potential difference value was obtained and the ratio was 3 in each case. He was the scientist Georg Simon Ohm. In 1827, Georg Simon Ohm found out a relationship between current and potential difference. A potential difference V across the ends of a metallic wire in an electric circuit is directly proportional to the current flowing through it at constant temperature. It is called Ohm's law. This Ohm's law definition is very important and I request students to completely memorize it. This is extremely important. It will be asked in exam in one form or the other. Potential difference V across the ends of a metallic wire in an electric circuit is directly proportional to the current I flowing through it at constant temperature, and this law is called Ohm's law. So V is directly proportional to I, or V by I ratio is a constant which is equal to R, and R is resistance. So V is equal to IR is another formula. V is equal to IR, or I is equal to V by R. So these are the different formulas that we get because of Ohm's law. Let's move ahead. Now, what extra he has said, that the SI unit of resistance is ohm and it is denoted by this symbol. Okay, fine. And according to Ohm's law, R is equal to V by I. So if the potential difference is 1 volt and the current is 1 ampere, then the resistance of the conductor is 1 ohm. So how do we define the relation? How do we define 1 ohm? We define 1 ohm as if the potential difference, okay, if the potential difference is 1 volt and the current is 1 ampere, then the resistance R of the conductor is 1 ohm. Okay, so 1 ohm is 1 volt by 1 ampere. A conductor having appreciable resistance is called a resistor. This is how a resistor looks like. It is used to control electric current. Okay, the current through a resistor is inversely proportional to its resistance, and If the resistance is doubled, the current gets halved. It has many practical applications. See, resistance and current are always inversely proportional. If the resistance is high, the current flow will be less. If the current flow is high, resistance will be low. So they are inversely proportional. So if the resistance is doubled, the current gets halved. If the resistance is halved, the current is doubled. Okay. So now there is another component such as a rheostat. What is a rheostat? A component used to regulate current without changing the voltage source is called the variable resistance. So rheostat is a variable resistor used to change the resistance. Now let's move ahead. Electrical resistance of a conductor. Set up a circuit by connecting 4 dry cells of 1.5 volt each in series with the ammeter 0 to 5 ampere range, leaving a gap XY in the circuit. Complete the circuit by connecting a nichrome wire in the gap XY. Okay. Plug the key, note down ammeter reading. Replace the nichrome wire with a torch bulb in the circuit and note down the ammeter reading. Okay, note down the ammeter reading. Repeat this with a 10 volt bulb and any material. The current is different for different components. Okay. The current is different for different components. In certain components, there is easy flow of electric current. Okay. Electric current, while the others resist the flow. Okay. Now let's move ahead. Within a conductor, electrons are not completely free to move due to the attraction by atoms. So resistance is increased and motion of electrons is retarded. See, this is a conductor, this is a battery. Current flows from negative to positive terminal, the light blows. Okay. If we put an insulator will block the current flow, no current can flow. A component that conducts electricity and has a low resistance is called a good conductor. A component with a high resistance is poor conductor, and it is often called as an insulator. Okay, it is often called as a insulator. It does not conduct electricity. Okay. Now let's go. The ammeter reading in an electric circuit with a nichrome wire of length L, we are assuming the reading as 1 ampere. Nichrome wire of twice the length 2L, here ammeter reading decreases to 1/2. Okay, a thicker or a larger cross section area nichrome wire of same length L, here reading is increased. If area is double, reading is also double to 2A. Okay, so what is it telling us? What it says is that in any current carrying conductor, the length is directly proportional to the resistance. The higher the length, the higher the resistance. Okay, this is an important topic, the factors in which resistance of conductor depends. It depends on 4 things. Or we can say even 3 things. First is the length. It is directly proportional to the length of the conductor. More the length of conductor is higher the resistance. Okay, so it is directly proportional. It is indirectly proportional to the cross section area. Cross section area means if I cut the nichrome wire, I get the cross section. So higher the cross section, lower is the resistance. Okay, and higher the resistance, lower is the cross section area. Now the third thing is the material. It also depends on the material. What is the material of the conductor? That also determines the that also determines the resistance. Now let's go ahead. The same thing as I told you, the length, the area of cross section and nature of material. Resistance of a uniform metallic conductor is directly proportional to its length and inversely proportional to the area of cross section. Okay, inversely proportional to the area of cross section. So whenever we get this R is equal to directly proportional to length inversely proportional to area of cross section, in order to remove the proportionality symbol, we insert another constant called as rho. Rho is a constant of proportionality and is called electrical resistivity of the material of conductor. It is a characteristic property of the material. So SI unit of resistivity is ohm meter. Okay, so resistivity what is the SI unit of resistivity? Ohm per meter. Since this is ohm, this is meter square, length will be meter. So 1 meter and meter square 1 meter will be cut. So ohm meter is the SI unit of resistivity. Resistivity. Let's go ahead. Okay. Factors on which resistance of a conductor depends. So this I already explained. Resistivity of metals and alloy is very low. They are good conductors of electricity. Resistivity of insulator is very high. Resistance and resistivity vary with temperature. Resistivity of an alloy is generally higher than that of its constant metals. Alloys do not oxidize or burn readily at high temperature, so they are used in electrical heating devices like electric iron, toaster, etc. See, this is an electric iron, this is a toaster. Okay. Question is asked, why an alloy material is used for ironing clothes or for the material of a toaster? The answer is that the resistivity of alloy is generally higher than that of its constituent metals. Alloys do not oxidize or burn readily at high temperature, so they are used in electrical heating devices like electric iron and toasters, etc. Now, tungsten is used for filaments of electric bulbs. Copper and aluminium are used for electrical transmission lines. Okay, now let's move ahead. Factors on which resistance of conductor depends. See, this is electrical resistivity of some substances at 20 degree Celsius. Okay. The material can be, this is a conductor. So these are all good conductors: silver, copper, aluminium, tungsten, nickel, iron, chrome, mercury, manganese, and these are the resistivity ratings for them. For alloys like constantan, like Cu plus nickel, this is the rating. For manganese, this is rating. For nickel, this is rating. Okay. Insulators are glass, hard rubber, ebonite, diamond, and paper dry. These are the ratings for the insulators. Okay. Now we do have some questions and problems. Now let us try to solve them. They are straightforward, and these will be solved by using Ohm's law formula. So how much? Okay. So by using Ohm's law, by using Ohm's law formula, how much current will an electric bulb draw from a 220 volt source if the resistance of bulb filament is 1200 ohms? So R is equal to V by I, and I is equal to V by R. V given is 220, R is 1200, so 0.18 ampere. Second, how much current will an electric heater draw from a 220 volt source if the resistance of heater coil is 100? So current is R. So R is V by I. So I is V by R. 220 by 100 is 2.2 ampere. Okay, so that's the current drawn by an electric bulb and electric heater from the same 220 volt source is different, that we have observed. Okay, that is due to the difference in the resistance in both the cases. I hope this question was clear, very straightforward. We have one more problem, and now let us see what this problem says. Potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? Very simple. First we will find the R in the case when the our heater is drawing 60 volt and 4 ampere. R is V by I, 60 by 4, so 15 ohms is the resistance. Now potential difference is increased to 120 volt, so current is I is V by R, 120 volt by 15 ohm, resistance remains same, so 8 ampere current is 8 ampere is the 8 ampere current is produced, or it is drawn. Okay, now let's move ahead and see similar problem. Resistance of a metal wire of length 1 meter is given, 26 ohm. We have the diameter in mm. We first convert it into meters, and that is 0.3 mm, 0.3 into 10 to the power minus 3 meter. It can be 3 into 10 to the power minus 4 meter. Length is given in meter. Resistivity will be found by rho is Ra by L, where A is pi d square by 4. Okay, where because the area of cross section is pi r square, R is d by 2, so pi d square by 4, we get the value. Okay, similarly one more question is there where the R1 needs to be found, where rho and L by A is given. We get 4 ohm. For second wire again we calculate R2 and we get the value as 1 ohm. Okay, you can go through the question, both the questions, and they are straightforward. This type of question can be asked, and this also can be asked. So fundamentally we have to be clear. We need to know the formula. R is equal to rho L by A, R is equal to V by I, etc. Thank you everyone for attending this session. I really hope it was useful. For today we stop.